Hi guys, Michael and Vinny here coming to you from the Lansing Community College Kennedy Cafe. I got a new project I'm working on for the Geek group. Hopefully we can see some results here in a couple of weeks. I'll be working with Craig Pontius in order to make an inverted pendulum robot. You can go ahead and YouTube that or Google that for some ideas. I'll also go ahead and take a second here and give you a couple links on the screen so you can see what I'm talking about. Right now, the project is in its infancies. We are doing the initial planning on that. We have a concept in place, and hopefully we'll be able to move forward on it soon. In order to make that happen, I need to come up with a list of materials and some more information for our fearless leader, Chris, and see if we can come to a common ground and look at some things that I need to make it happen. Immediately important is the $10 for the hardware for the Atmel programming microprocessor and the $70-something rotary optic encoder that we need. That's so expensive because it has a really high resolution. I think every cycle, every tick it makes is 0.35 degrees or something along those lines. So between those two things and a bit of stuff gutted from the scanner or printer or something along those lines, we should be able to have what we need. All right, we're back here. We've done some drawing and some sketch work. I'm joined by Mr. Pontius here. Yep. And we have some framework design concepts in place. Certainly not by any stretch of the imagination the final version, but we'll be able to build on this framework and hopefully get a working model in place. So if Craig, would you be so kind to hold up and we'll do our ghetto screen capture of ghetto.
If I can find it.
All right.
And we're there.
All right, we're looking at the model from the side, and we can see here the side plate, the base plate. We have two linear slides here and here. They're slightly large. This is actually drawn to scale. This is about how big I want to build this. I do believe the base is 6 inches in this direction here, 3/4 inches tall, and then the length of it to you and from along this pane is determined by the length of the slide bearings that we end up going with. These are a little large. They're kind of in there for conceptual drawing. I'm trying to find 3/8 to 1/2 inch for those. There'll be two of them, 1 and 2 right here, and then there'll be a small block here. My computer's lagging on me. How delightful. To hold the stepper motor that's located up here-ish, kind of over there. Yeah, freezing computer is horrible. The stepper motor can be replaced by a DC motor, but it's all depending on what we find and what we have available. In a slight other note, the belt will go off the tip of the motor here, and then above that will be a pulley so that belt can be out of the way. We're going to stop the video here, and we're going to go to the next slide in just a moment. Ooh. Okay, we have the next slide available now. This will actually be the carriage on which the pendulum rides. And I'm going to go ahead and do my fabulous ghetto screen capture of ghetto, and we will take a look at that next. So, right about there will work. So those linear slides we were talking about earlier will go through this block here. There will actually be two of these blocks, one behind the other. We're looking at it from the side again. We have our vertical plate here and our deck plate that goes through here. The screws are kind of drawn in about where I want them. I want 3 in here, but obviously I don't have a very good solution for drawing circles with me right now, so that is the way that is. We have our belt stop block right here. We have our rotary sensor here. The mounting bracket for that goes through here. There's a axle that goes through here. To connect the axle to the sensor, we'll use a little rubber sleeve that's located here. The pillow block is right here and right in there. And inside the center of that pillow block will be just a regular skate bearing. The axle will be sized to the bearing since I have those bearings. I have a bunch of those bearings. There will be a couple little stops on either side of the bearing to keep that centered. And then over here will be the mounting block for the pendulum. My goal is to make two different types of pendulums, one a solid bar and the other a double axle pendulum. I don't have that drawn up just yet, but it's pretty simple. There's a pair of legs, and in between the legs will be the second half of the pendulum, and that will be pretty simple to build. It won't actually be that complicated. So at this point, I'm quite confident that my sketchwork can be transferred over to a DXF solution, and the parts, a proper list of parts and prints of parts will be available soon. At that point, it's just a matter of securing the materials and the sensors and the bits, as it were, for the project, and to start assembly. Once the frame is assembled, we can start to test with code and see if we can't get the carriage to snap back and forth fast enough to do a self-erecting process. A couple of little things of note: I'm going to put zero limit switches on either side of the base plate so that the carriage can't, run off the slides. So if somebody was to try to push the pendulum and keep pushing it, obviously the cart will try to get underneath it, and if they push too far, the cart will be at the end of the track. At that point, what I think the solution is going to be is we'll program a fail and let the pendulum fall to 0 point, hanging down, and then go ahead and once it resets to the center of the stage, to go ahead and go through its erecting process so that it can get back up in the air, and that way people can play with it again. Okay, so I hope I've answered all the questions as to the initial process of getting this running. If there are any questions, go ahead and post them in the comments, and I will go ahead and address those as I am able. And we will go ahead and start securing bits and bits so that we can start assembly sometime soon. My goal is probably sometime around spring break to have a working something in place. And at that point, of course, we'll take the working module and donate it to the Geek group and allow them to put it on display with the rest of their small science projects that they have sitting in the Astro Lounge Cafe area. Thanks for your time, guys. Catch you later.